I'm Dr.B.Krishnaveni, Assistant Professor in Mathematics, Aditya University. Today I am going to discuss about diagonalization by orthogonal reduction. So that is how to diagonalize the matrix using orthogonal reduction. So previously we discussed about the diagonalization by another transformation, that is similarity transformation. Here we need to discuss with orthogonal transformation. So what the difference between these two means, here the given matrix must be a symmetric matrix. So at the end of this lecture, student will be able to diagonalize the given symmetric matrix into diagonal matrix by means of orthogonal transformation. So in order to diagonalize the given matrix using orthogonal transformation, first of all we need to check whether the given matrix is symmetric. So then only we will find the diagonal matrix of that using orthogonal transformation. So let us move into the topic diagonalization. So first we will get the definition for symmetric matrix. Let A be a square matrix of order n, then it is said to be symmetric if A is equal to A transpose. So whenever the condition A is equal to A transpose is satisfied, we call that matrix as a symmetric matrix. Now what is orthogonal reduction is? This is a transformation by which a symmetric matrix is reduced to diagonal matrix by means of a orthogonal matrix. That we call it as orthogonal reduction, which means we can transform the symmetric matrix into diagonal matrix by means of a orthogonal matrix. So now we will see what is the diagonalization process here. Let A be the symmetric matrix of order n, then there exists a orthogonal matrix P such that P transpose AP is equal to D. So we all know that what we can do in diagonalization, that is we will do P inverse AP, which gives diagonal matrix. But here we are using P transpose in the place of P inverse. Since here P is an orthogonal matrix, we know that P is orthogonal whenever P inverse is equal to P transpose. So that's what we can replace this P inverse with P transpose. Thereafter the equation becomes P transpose AP, that resultant gives diagonal matrix D. So this we call diagonalization using orthogonal reduction or orthogonal transformation. So now what the applications for this? The first one is very clear, that is we can use this process in order to find out the diagonalization of the given matrix, and it is also used to find out higher powers of a matrix. So in what we can calculate by means of this equation? So you can consider this equation and simplify in such a way that we can get the power of the matrix A power n is equal to P D power n P transpose. So now let us discuss about the working rule of orthogonal reduction. First we need to check whether A is a symmetric matrix, that is A is equal to A transpose. Next, find out eigenvalues and eigenvectors of A. Check eigenvalues are mutually orthogonal. For suppose if you are getting 3 eigenvectors x1, x2, x3. So when they were orthogonal means they must be mutually orthogonal. That means we need to check x1, x2 orthogonal, x2, x3 as well x1, x3. If all the three are orthogonal means we say that they are mutually orthogonal or else pairwise orthogonal. So once you got all the 3 vectors or all the eigenvectors are mutually orthogonal, then we will find out the normalized vector of that each vector. That means the next step is we will normalize the vectors. Next, write the model matrix P with the columns as normalized eigenvectors of A, which is an orthogonal matrix. So which is P transpose is equal to I, or else P inverse is equal to P transpose. Next, Compute orthogonal reduction given by P transpose AP. Once you calculated that, the resultant matrix is the diagonal matrix D, whose diagonal entries are nothing but eigenvalues of A. So, now let us discuss the same using the question here. So, the given question is diagonalize the matrix A is equal to the first row 1 1 3, second 1 5 1 and the third row is 3 1 1 by means of a orthogonal reduction. So, now what the very first step is? First we need to check the given matrix is symmetric matrix or not. For that we need to find out A transpose. What meant by A transpose is we need to exchange the rows and columns of A, which becomes A transpose. Hence, write down the first row as the first column in this matrix. First row becomes the first column, that is 1 1 3. Second row 1 5 1 becomes the second column here, that is 1 5 1. And the third row 3 1 1 becomes third column. And if you observe, this is again is equal to A. So, hence the condition is satisfied. Therefore, here A is symmetric matrix. So, once it is symmetric, we need to proceed our process, that is very first step is the next step is we need to find out eigenvalues and eigenvectors. In order to calculate that, first need to consider the characteristic equation. So, characteristic equation is given by lambda q minus S1 lambda square plus S2 lambda minus S3 is equal to 0. So, usually you know the characteristic equation is that A minus lambda is equal to 0. Since it is 3 by 3 matrix, directly you can use this formula. And here what S1 is sum of diagonal elements of A, which is given by 1 plus 5 plus 1, that is equal to 7. And S2 gives sum of the cofactors of diagonal elements of A. So, first let us consider the diagonal element 1, cofactor, since it lies in first and first column. So, the sign is positive. I need to delete the row, delete the column containing that element, and how to consider the det of remaining elements, which is given by det of 5 1 1 1 plus. Next is A22, that is second diagonal element. In the same way, here again positive, and delete the row, delete the column containing that element. Det of remaining elements given by det of 1 3 3 1. Similarly, the cofactor of 1 is given by det of 1 1 1 5, which is equal to 4 minus 8 plus 4. We got that value is equal to 0. So, and S3 representing det of A. So, det of 3 by 3 matrix, on calculating you got the value is equal to minus 36. Now, substituting all S1, S2, S3 values in this equation, we got the characteristic equation as lambda cube minus 7 lambda square plus 0 into lambda minus of minus 36 is equal to 0, which is lambda cube minus 7 lambda square plus 36 is equal to 0. Now, need to solve the equation. For that, we got one root is lambda is equal to minus 2 by using synthetic division. Thereafter, you can find out the remaining roots. You got the remaining roots are 3 6. So, the roots are minus 2 3 6, which are the eigenvalues of the given matrix. So, now for each eigenvalue need to find out eigenvector. So, we all know that what is meant by eigenvector is it is a non-zero vector such that A minus lambda I x is equal to 0. So, now for each lambda let us calculate x, which gives the eigenvector. So, first what is A minus lambda I is? So, A minus lambda into I gives the matrix 1 minus lambda 1 3. 1 5 minus lambda 1 3 1 1 minus lambda. Now, A minus lambda I x is equal to 0, that is A minus lambda I x is column xyz is equal to 0, that is column 0 0 0. So, now use this equation to find out eigenvector. First substitute lambda is equal to minus 2, then the equation becomes A plus 2I of x is equal to 0 and just now we calculated, in that substitute lambda is equal to minus 2. Then we got the equation as 313,171,313 xyz is equal to 0, 0, 0, which gives the system of homogeneous equations. So, you can write the system given by 3x plus y plus 3z, right. So, 3x plus y plus 3z by means of the first row. Using second row, you got the second equation, and third row the third equation, which gives homogeneous system of linear equations. Now, in order to solve this, clearly you can see here, out of two equations are identical, which means the rank is equal to 2. And how many variables are there? X, y, z, those are 3 variables. So, hence clearly here it is rank is less than number of variables. Hence, the system has infinite number of solutions. So, now in order to get that, let us consider any 2 equations from this. Since 1 and 3 are identical, let us consider 1, 2 or 2, 3. Here we have taken x plus 7y plus z is equal to 0, 3x plus y plus 3z is equal to 0. So, previously if we observe, to find out the eigenvector, we have used some another method. You can follow that method, or this is another method which is very easy to calculate an eigenvector. So, now to find out the solution of these 2 equations with the 3 unknowns. So, follow the pattern like, first need to consider the coefficients of each equation, like first take y coefficient, the first equation, next z coefficient, next x coefficient, next y coefficient. Follow the same for the second equation, first y coefficient, next z coefficient, thereafter x, next y. So, here you can take as x, y, z. Now, you can write this as x by det of 7113 is equal to y by det of 1133 is equal to z by det of 1731. So, which gives x by 20, y by 0, z by minus 20. In simple, we can write it as x by 1 is equal to y by 0 is equal to z by minus 1. And this gives the eigenvector x1 is equal to 101, corresponding to the first eigenvector, that is lambda is equal to minus 2. Next, similarly, we will calculate the other eigenvectors. Now, take the second eigenvalue lambda is equal to 3. By using the equation, you got a minus 3 of x is equal to 0. Substitute lambda is equal to 3. And doing this, we got the system as minus 2, 1, 3, 1, 2, 1, 3, 1, minus 2, x, y, z is equal to 0, 0, 0. Write in the form of system, minus 2x plus y plus 3z is equal to 0, x plus 2y plus z is equal to 0, 3x plus y minus 2z is equal to 0. So, now since it again an homogeneous system having identical equations, if you observe keenly, right, again the rank of this equation system must be equal to 2, which is less than number of variables, that is 3. Again it has infinite number of solution. Now, let us solve the same process. Let us take these 2 equations, x plus 2y plus z is equal to 0, 3x plus y minus 2z is equal to 0. So, write down the pattern for that. First, consider the equation 1 and write down the coefficients as first y coefficients, next z coefficient, next x coefficient, next y coefficient. Now, from the second equation, y coefficient 1, z coefficient minus 2, x coefficient 3, thereafter again y, means first y, z, x, y. In that way we need to take, thereafter you can put here as x, y, z, then write this equation, x by 2, 1, 1 minus 2 is equal to y by det of 1, 1 minus 2, 3 is equal to z by determinant of 1, 2, 3, 1. So, on calculating this becomes x by minus 5, y by 5 is equal to z by minus 5, which further can be written as x by minus 1 is equal to y by 1, z by minus 1. So, therefore, what the eigenvector is, x2 is equal to 1 minus 1, 1. Next, corresponding to lambda is equal to 6, by taking lambda is equal to 6, we got this equation, that is minus 5, 1, 3, 1 minus 1, 1, 3, 1 minus 5, x, y, z is equal to 0, 0, 0. Then write down the system, minus 5x plus y plus 3z is equal to 0, x minus y plus z is equal to 0, 3x plus y minus 5z is equal to 0. So, again here is the rank is 2, which is less than number of variables, since it has infinite number of solutions. On solving the same process, we got x by det of minus 1, 1, 1 minus 5 is equal to y by det of 1, 1 minus 5, 3 is equal to z by determinant of 1 minus 1, 3, 1. So, that gives x by the determinant value is 4 is equal to y by the det value is 8 is equal to z by the det value is 4, which can be written as x by 1 is equal to y by 2 is equal to z by 1. Therefore, the eigenvector is given by 1, 2, minus 1. At last, you got all the 3 vectors x1, x2, x3. So, now in order to write down the model matrix, first need to check the orthogonality. So, in order to check the orthogonality, first check whether each pair is orthogonal. So, let us consider the first pair x1, x2. To say that x1 is to are orthogonal, we need to get x1 transpose into x2 must be equal to 0. So, let us check that. So, x1 transpose into x2. Since x1 is column 1, 0, minus 1, x1 transpose becomes a row 1, 0, minus 1 into x2. Column 1 minus 1 0. After multiplication, we got this is equal to 1 into 1 1, 0 into minus 1 is 0, minus 1 into 1 is minus 1. So, on calculating we got the value is equal to 0. So, hence x1 and x2 are orthogonal. Next, take the second pair x1, x3. Calculate x1 transpose into x3. So, x1 transpose is 1, 0, minus 1 row and x3 column 1, 2, 1, multiply it, 1 into 1 is 1, 0 into 2 is 0, minus 1 into 1 is minus 1 equal to 0. Next, calculate x2 transpose into x3, row 1 minus 1, 1, x3 column 1, 2, 1, multiply it, 1 into 1 is 1, minus 1 into 2 is minus 2, plus 1 into 1 is 1. So, you are getting again 0. So, hence here again you are getting x1, x3 orthogonal as well x2, x3 are also orthogonal. Therefore, we can say that all the 3 are mutually orthogonal, that is eigenvectors are mutually orthogonal. Hence, we can find out the normalized form of those vectors. So, in order to do that, first of all find out the norm of each vector. So, we all know that if x is equal to a, b, c, what is the norm of that vector is? Norm x is equal to root of a square plus b square plus c square. So, let us calculate norm of each vector. Norm x1 is equal to root of 1 plus 0 plus 1, or else you can write what are the vectors here first. x1 is 1, 0, minus 1, x2 1 minus 1 1 and x3 is 1 2 1. So, find out the norm of x1, root of 1 square plus 0 square plus minus 1 square, that is plus 1 root to 2. Norm x2, 1 square root of 1 square plus minus 1 whole square, which is a 1 plus 1 square 1, that is root 3. Norm x3 is equal to square root of 1 square 1 plus 2 square 4 plus 1 square 1, that is equal to root 6. So, which given by What is the normalized form is x1 by norm x1, that is given by, what to do here is we need to divide the each element of that vector by its norm, that gives the normalized form of the vector. So that's what x1 by norm x1 gives the normalized form of the vector x1, that is given by 1 by root 2, 0 by root 2, minus 1 by root 2. x2 by norm x2, 1 by root 3, minus 1 by root 3, 1 by root 3. x3 by norm x3, 1 by root 6, 2 by root 6, 1 by root 6. Hence, now we can write the model matrix whose columns are normalized eigenvectors, which is given by P is equal to 1 by root 2, 0 minus 1 by root 2, 1 by root 3 minus 1 by root 3, 1 by root 3, 1 by root 6, 2 by root 6, 1 by root 6, giving each column are nothing but normalized eigenvectors. Now, orthogonal transformation is given by P transpose AP. So, write down what is P transpose. A is the given matrix, P. Calculating the multiplication of these three matrices, you got the resultant matrix is 2 0 0 0 3 0 0 0 6. That is, we got a diagonal matrix in which the diagonal elements are eigenvalues. Hence, in this lecture, what we did is we have done the diagonalization of the given symmetric matrix. That means we converted the given symmetric matrix into the diagonal matrix by means of orthogonal reduction. So, in order to do the orthogonal reduction, first we need to see whether the given matrix is symmetric. Then you can apply orthogonal reduction. Finally, you can calculate the diagonalization of that matrix using orthogonal matrix, which we call it as orthogonal transformation or orthogonal reduction. Thank you.